Welcome, class, to math. Cheers! Go math! Give me an S, S. Give me a Y, Y. Give me an M, M, E, T, R, Y. What's that spell? Symmetry! Go symmetry! Woo! What is symmetry? You ask. That's a good question. Let's see. Reflective symmetry is a figure that can be divided into two parts, and each half looks the same as the other. Reflective symmetry. What divides the thing in half, you ask? That's called the line of symmetry. The line that divides in half is the line of symmetry. Do I have symmetry? Let's see. If we use a mirror and as the line of symmetry we put it right down my middle, you can see. Do I have symmetry? Yes, I do. I've got reflective symmetry. Yes, I do. I've got reflective symmetry. How about you? Woo, yes, you do. Because if you draw a line down the middle, the right half and the left half look the same. How about with regular polygons? Let's find out. How about if we get a polygon with 1, 2, 3 sides? What would that be? Did you say a triangle? I hope you did. Because a triangle has 1, 2, 3 vertices, 1, 2, 3 sides. But how many lines of symmetry? Well, we can divide it and find out. If we draw a line from one vertex through the middle of the other side, that's one line of symmetry. Now, we can also divide through the other vertex. If we start on this side and divide through this vertex, through the other side, that's two lines of symmetry, but we have one more vertex. If we start on this side and divide through to the middle of the other side, that gives us 1, 2, 3. 3 lines of symmetry. 1, 2, 3. 3 lines of symmetry in our regular polygon triangle. Yay! So it has the same number of sides and vertices as it does lines of symmetry. Does it always work that way? I don't know. Let's try again. This time let's use a 1, 2, 3, 4, 5 5-sided regular polygon called a did you say Pentagon? I hope so, because that's its name. Oops. All right. Erase our previous lines of symmetry. See what a pentagon will do for us today. All right, we have 1, 2, 3, 4, 5 vertices on a pentagon. 1, 2, 3, 4, 5 sides on a pentagon. How many lines of symmetry? Let's divide and we will see. Draw through the vertex to the other side. That's one line of symmetry. Divide through this vertex to the other side. Whoops, that's 2 lines of symmetry. Divide through this vertex to the other side. That's 3 lines of symmetry. Another vertex here I see. Divide. Another line of symmetry. And finally, our last vertex. Divide through this vertex. And what do we see? That's 1, 2, 3, 4, 5 lines of symmetry. So the pentagon also has same number of sides, same number of vertices, and same number of lines of symmetry. But these are both odd-numbered regular polygons. Does it work with even numbers as well? Let's find out. How about a regular quadrilateral? Who knows what that is? Quadrilateral has 1, 2, 3, 4 sides. Then we could also call it a square. Thank you, my lovely square. And let's try one other. Square spins. One other regular polygon with, let's go, 1, 2, 3, 4, 5, 6 sides on this polygon, and that would be called a hexagon. So we have our square and we have our hexagon. How many lines of symmetry do we see in each of these? Let's start with our square. If we divide through our vertices just like on the other ones, we'll start with the square. We have 1, 2, 2 lines through the vertices. But are there other places? We can also divide through each of the sides. So if we divide through the top side to the bottom and the right side to the left, that gives us how many lines of symmetry? We have 1, 2, 3, 4 lines of symmetry in our square, just like before. 4 sides, 4 vertices, 4 lines of symmetry. Will that work with the hexagon? Let's divide and find out. Draw our line through the vertices. 1, 2, 3. 3 lines through the vertices. How many through the different sides? Let's try. 1, 2, 3 more through the sides. So we have 3 through the angles, 3 through the sides. That's a total of 6 lines of symmetry. Count them with me. 1, 2, don't spin on me, 2, 3, 4, 5, 6. 6 lines of symmetry going around our hexagon, you see. Good job! Now you know about reflective symmetry. Is there any other kind that we can see? Yes, there is. There is also rotational symmetry. Rotational symmetry is when a figure can be rotated in a full circular spin, but it will look the same before it does a complete rotation. So do regular polygons also have rotational symmetry? Let us see. Let's take our little triangle and we will stick it here. Now, as I spin our triangle, will it look the same before it gets back to A? We will spin it once Ooh, look at there. Now C's at the top and A's at the side, but they still look the exact same before I started spinning. And spin it again. B's at the top, A's at the side, but it still looks the same. And one last time, back to our original position. So yes, it has rotational symmetry. Well, it works with every regular polygon. If you spin them, they will look the same when you get to the other side. But does it work with letters? We have an M, A, T, and H. If we spin it, do they look the same? Not an M, not an A, not a T, and not an H. Does not work when we spin it that way. Let's try again. Spin it once more. Not an M, not an A, not a T, but wait! H looks the same. So H has rotational symmetry because before it's been spun all the way, it looks like an H, only halfway. Still not the same, but here we go. H was the same when it was upside down. So here's the question to end it all. Do we have rotational symmetry? Let's find out and see what we can see. No rotational symmetry. I do not look the same when I'm upside down or side to side as I spin around. So we only have reflective symmetry, but not rotational symmetry. You can practice your symmetry when you look at your practice set. Call out what you see and cheer your way through this math lesson. You can do it. Yes, you can.